All right, we're doing the last section of this unit, Chapter 2, Section 7. It's Learning Plan 1.9 on absolute value equations and inequalities. We're going to understand what it means by distance. We're going to solve equations that have absolute value. We're going to solve inequalities that have absolute value, some less than, some greater than. We're going to solve absolute value equations that involve rewriting, and then solve equations that have an absolute value on both sides. So let's get started. What does it mean to have absolute value? Well, absolute value of a number written in braces or straight lines is the distance from that point to 0 on the number line. So the absolute value of 5 and negative 5 is both 5 because both of them are 5 from 0. So, how do we understand that? To solve an equation where they are equal, you have to say x is k or negative k. And usually you end up with 2 points. If you have a greater than, then you're going to have it's either greater than k or it's less than negative k, in which case you're going to have going out. If you have a less than sign, it's going to be a between. Okay, so let's get started. First of all, we want to know what is the distance between 2x and 7 that it's less than 6. So the distance from 2x to 7 is less than 6. The only one that fits that is letter C, because remember, it could be negative 6. Okay, so we've got an equation first. K is a positive number. Obviously, if it's negative, it won't work. So we're going to have two solutions. Either 3x minus 4 equals 11, or 3x minus 4 equals negative 11. Those are our two choices for an inequality or for the absolute value like we have here. Okay, so let's add 4 to each side, and we get 3x equals 15, which means x equals 5. Add 4 to each side here, we get 3x equals negative 7, divide both sides by 3, x equals negative 7/3. So we've got two answers, 5 and negative 7/3. And that's how you do these. So let's look at the one that you're supposed to try for yourself and see how you do. So our two equations are 6m plus 5 equals 6, or 6m plus 5 equals negative 6. Subtract 5 from each side, and we get 6m equals 1, 6m equals negative 11, or m equals 1/6, m equals negative 11/6. Now, if we have an inequality, notice there's going to be two different cases. One of them is for the less than symbol, the other one is for the greater than symbol. Let's try this one first. We still rewrite it as two separate inequalities. 3x minus 4 is greater than or equal to 11. We just write it exactly that as it is without the absolute values. Or 3x minus 4 is less than or equal to, so we change the sense and we change the sign. Add 4 to both sides. 3x is greater than or equal to 15. X is greater than or equal to 5. Add 4 to each side. 3x is less than or equal to negative 7, x is less than or equal to negative 7/3. Okay, so on our graph, our two critical values are at 5 and negative 7/3. X is greater than 5, or x is less than or equal to negative 7/3. So our interval notation will be negative absolute value, comma, negative 7/3, bracket, union, bracket, 5, comma, infinity, close parentheses. Okay, you do this one. So it would be x is greater than 1, or x is less than negative 1. Greater than 1 would be parentheses. Well, let's get our two, Let's get our two critical values, negative 1, 1. It's greater than 1 or less than negative 1. It looks like it's this one right here. And then our interval notation would be negative infinity, negative 1, parentheses, union, 1, infinity, parentheses. All right. Now we've got one that it's going the is less than. Okay, so we would rate it the way it is. X is less than or equal to 10, or x is greater than or equal to negative 10. I'm sorry, not or, and. If it's less than symbol, it's going to be and. Okay, so our two critical values are at negative 10 and 10. Got a bracket here at negative 10, a bracket at positive 10. It's like we're right here. X is less than or equal to 10, and x is greater than or equal to negative 10. So anywhere in between there will make that inequality true. So if you have a less than symbol, and if you have a greater than symbol, get the methods described apply when the constant is alone on one side of the equation or inequality and is positive. Absolute value equations and absolute value inequalities translate if it's a greater than sign. If it's a greater than sign, translate into or. If it's a less than sign, translate into and. An or statement cannot be written in three parts. Okay, so this one here we have to rewrite to get the 4 on the other side. So the first thing we're going to do is subtract 4 from each side, and we get 3x plus 2 absolute value equals 11. Now we can solve it just like we did before, where we would take the 3x plus 2 equals 11, or 3x plus 2 equals negative 11. Remember, you change it to negative, and now we're going to subtract 2 from each side, and we get 3x equals 9, so x equals 3. Subtract 2, 3x equals negative 13, x equals negative 13 thirds. So it's either 3 or negative 13 thirds. All right, so here's an inequality that involves rewriting. So we've got y plus 3, absolute value, minus 5 equals 8. The first thing we're going to do is to get the absolute value all alone by adding 5 to each side. y plus 3 absolute value equals 13. So y plus 3 equals 13, or y plus 3 equals negative 13. Subtract 3 from each side, and we get y equals 10, or y equals negative 16. Pretty simple stuff. Let's see what the next one is. Now we've got an absolute value on each side. If that's the case, then notice we're going to rewrite it and put a negative sign in front of the absolute value on the left-hand side. Okay. So we've got an absolute value on each side. Our first case is 4x minus 1 equals 3x plus 5. That's easy enough. The other case that we have to write is 4x minus 1 equals negative 3x plus 5, which would be 4x minus 1 equals negative 3x minus 5, right? This negative comes out into there. Add 3x to each side. We get 7x, and then add 1 to each side equals negative 4, so x equals negative 4/7. Over here, subtract 3x from each side. We get x, and then add 1 to each side equals 6. So our two solutions are x equals 6 and x equals negative 4/3, or 4/7. Okay, so there are some special cases, and one of them is you have to have an absolute value that is greater than 0. And it only is going to be 0 if the expression is equal to 0. So for instance, this case, we would say it's the null set because you can't have an absolute value equal to a negative number. Okay? Absolute value x is greater than negative 1. Now this we can solve. Okay? If the absolute value is greater than negative 1, then x is greater than negative 1. And then with the greater than symbol, if you remember, greater than we translate as, I got to make sure I got it right. Greater than translates as an or. Okay? So x is greater than negative 1, or x is less than positive 1. No, that can't be, because it can't be less than positive 1. I must have made a mistake there. Just a second. Let's see here. Is greater than negative 1. Well, any number is greater than negative 1. So we would say all real numbers, or in negative infinity, comma, positive infinity. There's nothing to solve there, because any number has an absolute value that's greater than negative 1. That was a hard question. Okay, if you have any questions,